Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm responding to a question submitted by a student. This is a word problem, and we have to read the word problem and figure out how to fit this to a sketch of trigonometric sketch, either sine or cosine. And you could use either one. Because this tide that we're modeling here is we're starting it at high tide, and I think for that reason I'm going to use cosine. It just makes it easier because we're starting at a maximum. So I'm going to start the sketch now and see if we can get something going here that's reasonable. So we know that there's a high tide every 12 hours, so we know therefore that there's a maximum here, and then there's another maximum here, and that's occurring at 12. So those are the two high tides. And we're told that 6 hours after high tide, we have a low tide. So here's 6 hours, and now my low tide is here. So I have a high tide here, and a low tide here. And so this lends itself very nicely to a cosine curve, which I'm just going to sketch like this. The cosine curve, I always say to students, think about an urn or a vase of flowers, and that's what the cosine curve looks like. And now we can fill in these values if we want to. And we're just missing the y values here. The water level at high tide is 10 feet above the water level for low tide. So that means this is 5 here and -5 here, you see, because the high tide is 10 feet above the low tide. So from here to here is 5, and 5 is 10. So that completes the sketch. So it takes a lot of practice to do this. It's hard at first. It's not that hard after a while. The only memorizing that you really have to do, I'm going to put in red here. There's some memorizing. You should memorize the general form of the cosine curve. So it's y equals a cosine of b times x minus h and k. So A is the amplitude, B is the period, I'm sorry, 2 pi over B is the period. Let me just put it in there now. The period is equal to 2 pi over B, actually absolute B. H is a horizontal shift, K is a vertical shift. And you have to remember the parent function, which is y equals cosine of x. And you have to just sketch the parent function and then modify it. You might have to slide it left or right if h In this case, h is 0, so we're not doing any horizontal shifting or phase shifting. And you might have to slide it up and down, which would be represented by k. In this case, there's no vertical shift here, no horizontal shift. So h and k are 0, and we don't have to worry about them. We do have to get b. You can see that the period is 12 here, so we have to solve for b. So 12 is equal to 2 pi over b. And so b, b is going to be equal to pi over 6. So now we're ready to write the equation of this curve. So y equals, now the amplitude is 5, obviously. The amplitude is the distance from the midline to the max, from the midline to the minimum. So it's going to be 5 cosine pi over 6 x, because h is 0 and k is 0. And that's all there is to it. So that's our formula. That's the part A. Part B, they want to know what's the height of the tide at 11 a.m. I see that this needs to be shifted over. You can't, it's just cut off a little bit. So let me move it over so you can see it. There we go. Okay, so part B is the height at 11 o'clock. Well, this represents 1 a.m. The high tide is here, 1 a.m. and 1 p.m. This is the high tide. And so 11 o'clock, 11 a.m. would mean that x is 10, because it's 10 hours after 1 a.m. And so we just plug 10 into this. I'm going to get y equals 5 times the cosine of 10 pi over 6. And on my calculator, I get 2.5. Make sure your calculator is in radian mode. So if we wanted 11 a.m., it would be somewhere around here. Let's see, 11 a.m. would be, yeah. So this is not very well positioned. The 9 is going to be really closer to this. I can't really draw this to scale. But it's 10 hours beyond the start of the curve, which is 1 a.m. So just to give you a little bit more, a drawing that's a little bit more to scale. So what we're getting here is an answer of 2.5. So that would be rough. Oops, wanted to change color. And that didn't change it. Okay, I got it now. So that's 2.5 here. And you can see it's, we're looking at 10, wherever 10 is. And we're just saying 10 is about there, well, roughly there. And so the sketch is not precise, but it's a reasonable answer, 2.5. Now they actually want to know how far above low tide this is. Well, that would be 7.5. So if you wanted the low tide answer, it would be 7.5. It's 7.5 feet above the low tide. And that's all there is to it. So these are a little tough in the beginning. Your textbook should have plenty of problems like this. I'm also not crazy about the way this one has been worded, but I mean, it's doable. You just have to kind of parse out the information and work on that. But these are not that hard once you do about a dozen of them. You'll start to get used to them. Okay, that's it for this one. I'll see you again next time. Bye-bye.